Okay, Mikey, this is Universe Simulator. This is a simulation of our solar system. Now I know, it looks complicated. Looks very, very complicated to you. But we will simplify it for you. Now what you can see here is the inner solar system. Here is the Sun. Here is Mercury. Wait a minute, I'll pause it. Here is Mercury. Here is Venus. And here is Earth. You'll notice that every time I highlight them, it will show their orbits. This is the path that they will follow around about the Sun. And if I play it, you'll see that they follow those paths. Right? You with me so far? Okay. Now, what we'll do here is we'll zoom in on Earth. This is the Earth. Sun way over there in the distance. This is the Earth. Beautiful, isn't it? Now, here is Canada. Lovely little place. Never been, but I'd love to go. Now, we're going to slow this down to go at 1 day per second. That's it. Going at 1 day per second. And you'll see the Earth is spinning. Every now and again, you can see Canada zipping past. Right? We'll slow it down to 1 hour per second. Here comes Canada. And America, obviously. Hurtling past. Tell you what, let's go. Real time, we'll go 1 second per second. This is what happens in space. Real time. This is how fast the Earth is spinning each second. Okay. Like that. We want to speed it up a little bit. We want to go up maybe back to a few times. "17 minutes every second. Let's get up a bit more. In fact, do you know what? Let's go. We'll go 1 hour per second. Okay. Right, so this will take 24 hours for the Earth to rotate. So if we stay here on the Terminator line, this is where Twilight is, by the way, Mikey. You can see Canada there. Now if you count 24 seconds, Canada will come back. There you go. Right, now I'm going to pause it for a second, just to get a bearing here. I'm going to zoom out, because I want to fast forward this a little bit to a certain point in time, okay? So we're going to jump it up to 1 day per second. 1 day per second. And we'll get it going. Now that's too slow because I want to bring Venus over to here, right? So we're going to need to go 1 month per second. I want to bring Venus just about there. Okay? Anyway. Right, we're going to have to change the speed again, although we are actually quite close. Okay, that's not bad actually. We've got Saskatchewan on there. Right, so this is Canada. I think we actually need to go a little bit backwards. Just get it into the right place. Okay, there we go. We have Canada roughly at twilight. Okay? So this is Canada at twilight. Now we'll zoom out. Remember, this is the Earth, this is the sun side, this is the night side. So we'll zoom out. Now remember, if you are in Canada and you're looking towards the horizon where the sun is going down this way, that will be up into the sky. Only slightly up because you'll be looking just above the horizon. And Venus will be visible. See? This is how it works. Okay, so let's move forward a couple of months. We'll make it 0.5. We'll move forward a few months. Oh, we're going backwards. Move forward a few months. You notice Venus is catching up to the Earth. Okay, now, there is Venus where you have it in your picture, in your diagram, your example. Do this again, we'll get... Oh shit, that's gone fast. We'll get Canada on the twilight. Right. Canada on twilight again. We'll zoom out. Venus will not be visible because it'll be right in front of the sun. Actually, that's almost a transit. I mean, no, it's no. Venus is far too high to be a transit. It would need to be the opposite side. But you will not be able to see Venus from Canada at that point, because it will be over the horizon. Okay, so let's bump the speed up again. We're going until Venus is in front of the Earth. There we go. That's probably, let's go a wee bit further. About there. We'll zoom in again. Now this time we're going on the morning side. I'm going to wait until Canada gets to morning. There's Canada. Still quite a bit away from it. Here it comes, here it comes. Here it comes. Boom. Twilight again. This time we have the morning. Again, look at the top. Here is the day side. Here is the night side. Canada, just in twilight. We'll zoom out. Venus is above the horizon. Venus is visible when you look up at just above the horizon. Just above the horizon. Now, if we play that slowly, where's Venus? Venus is over there, above you. Now we'll play it slowly. Now, Canada in daytime, can't see it because the sun's up. Let it go, let it keep going, let it keep going, all the way around. Here she comes. Here she comes. There's Canada on the night side. Now, on the night side, we'll zoom out. We'll zoom out. Do we see Venus from the night side? No, we don't. Might see Jupiter. We won't see Mars at this point because it's on the opposite side of the solar system. But we certainly won't see Venus. Not in the night side. We will never see Venus in the night side. There is, of course, one exception to that, which is the equinox. I don't really need to go into that just now, but that'll be when the north pole of the planet, it's actually not far off yet at this point, the north pole of the planet is pointing towards the sun. If you are up at one of these areas up here, nice and high up north, you will be able to see Venus over the horizon. It's actually not a bad time that I've stopped it at. I don't think we're exactly in the equinox, but goddamn close. You can also see Mercury for here as well. Let it play for a few seconds. Ooh, look at that. Brazil will be able to see both Mercury and Venus right now. Mercury may be a little bit difficult. There we go, the east coast of the US will be able to see Venus from here. All the way up through to where you are in Canada, you'll be able to see it there. All the way over there. Above the horizon. as the sun is rising. This is orbital mechanics. This is a great program to look at it from. You get a great idea of how the planets move for this. It certainly works a whole lot better than setting up a couple of bottles and a torch in your hall, because you are not getting the orbits of the planets, the actual movement of the planets, and the angles that you can see it from. And just for the sake of it, I'm going to leave it on this because, god damn, it's beautiful. This is going by at 0.2 months per second at this point. 0.26 months per second at this point. Great idea, actually. Let's put it on 1 month per second. 1 month every second, the Earth will orbit the planet, the Sun, in 12 seconds. Every 12 seconds, the Earth will make a full orbit. And only as Venus comes up to pass Earth will we be able to see it in the sky. Because at all other times, it will be hidden from us during the day side. Here it goes, it'll be visible at night there. And now it'll be visible at morning. Then it won't be visible again for another, roughly, I would say 9 months. Here it comes again, Venus coming up again. And that'll be visible. And visible again. And then not visible. And I'm going to stop it here. I'll focus on Earth again. Because you see what's up here? This is Mars. Now the night side, again, this way. It's the dark bit. If you look up into the sky here, you will see Mars. And you will see it for a long time. It will track across the sky in the night side until the point where Earth gets past it. It will still be visible. It will be visible at twilight now. Still be visible. And now it won't be. So this is it, Mikey. This is how it works. Venus is only visible during twilight. It's not visible in the middle of the night. It's not visible behind the Earth at night. It's visible over the horizon, just above the horizon. At twilight, that is in the evening, when it's coming up to pass Earth in its orbit. And in the morning, just above the horizon, when it's in front of Earth in its orbit. I don't know how else I can explain this to you. I mean, I could get a globe and some bottles and I could recreate this in my living room. A little bit of advice for you there, Mikey. Use your living room. Much more space to actually recreate the orbits. See, doing it in your wee hall like that and having them all in a straight line, that's just stupid. You cannot see the orbits. You cannot see the angles. And you cannot get Venus into a position in that little hall where it will be visible from the twilight side of the Earth. Use your living room. Better yet, go outside. Use a large open space. Now, thank you for watching this, Mikey. I know you probably will not, but who cares? I'm going to put it up anyway.